This is a lesson for 16-5. What you're doing today is looking at graphs and interpreting the meanings of graphs. Things like the rate of change and the Y-intercept and the X-intercept. Those are all things that we're looking at on these graphs. They love these type of questions on the Regents exam because they're very easily made into multiple choice type questions. So when we take a look at this first one, it says we're going to be looking at this graph for all of the examples today. So this graph, the graph shows the percent of charge remaining on a cell phone battery over time. So you'll notice that the charge of the battery, it goes down and then it goes straight across and then it goes down again and then it goes back up. So first of all, is this graph a function? So this is one of those things that they could easily make into a multiple choice question. They could give you 4 different graphs and ask which one is a function or which one is not a function. Is this a function? Well, remember that it fails the vertical line test if there's 2 dots right directly above each other. When we take a look at this graph, is there anywhere on this graph where there are 2 points directly above each other? No. Therefore, is it a function? Yes, it is. All right. Yes, this is a function. It passes the vertical line test because there's not a point anywhere on there where there's 2 points right above each other. Now, take a look at question number 2. What is a possible scenario for each segment on the graph? So what could be going on here in segment A, where our battery is going down? You're on your phone. You're using your phone. Maybe you are playing a game on your phone. All right, maybe you're playing a game on your phone. So the battery power is going down. All right, the battery power is going down. What could be happening in B? You're not on it at all. All right, it's just sitting in your pocket or sitting on a table, and it's doing nothing. So, but think about it. It might not be just sitting on a table. It might not just be in your pocket because does the battery still go down even though you're not on it? Yeah, so what's really technically happening here that it would stay exactly the same? It's powered off, all right? It's turned off during that time. Because that way the battery won't go down at all. Because even if you're not using it, it's going to go down slower. So what's happening in C again? Yeah, it's turned on, all right? It's turned on. You might be using it, all right? You might be using it slightly. And then what happens in D? It's charging, all right? It's charging because the battery life is going back up. So again, those are just possibilities. Question number 3, what does the Y-intercept mean in the context of the problem? Now the Y-intercept, remember, is where the line crosses the Y-axis. So this one crosses the Y-axis right here. What is that point? What does that point mean in the context of the problem? What percent is it at? 100. So it is fully charged, right? It is fully charged battery. It is at 100%. Now, this is what you're going to be doing for most of the homework questions today. Find the rate of change for each segment. What you have to do is you have to think about this as between points, all right? Segment A goes from this red dot to this red dot. Segment B goes from here to here. Segment C from there to there. Segment D from there to there. In order to find the rate of change is just another word for slope of your graph. So what we're going to do is we're going to use this slope formula. Y2 minus Y1 over X2 minus X1. And we're going to find the slope or the rate of change for all 4 of those segments. So in segment A, we're going, now remember that all points are written X comma Y. Remember that your X value is how many you go over, your Y value is how many you go up or down. Obviously, we can't go down in this type of graph. So this point, 0, 100. So we're going to find out the slope from 0, comma 100, which is this point right here, to this point, I'm going to say that that's right at 3 because it looks like it's exactly halfway in the middle. So I'm going to figure it out to 350. So that's looking at segment A, going from that point to that point. All points are written X, comma Y. So 0 is an X, 100 is a Y. 3, comma 50, 3 is an X, and 50 is a Y. 0, comma 100 is your first point. So these get 1s. 3, comma 50 is your second point. So these get 2s. Now we're going to sub the numbers into our slope formula. Y2 minus Y1 over X2 minus X1. So I'm going to draw my fraction bar. I'm going to put my 2 minus signs. Those are in every single question because they're part of the formula. Y2 minus Y1, 50 minus 100. X2 minus X1, 3 minus 0. 50 minus 100 is negative 50. 3 minus 0 is 3. I'm actually not going to leave that as a fraction. I'm going to make it into a decimal. Negative 50 divided by 3, top divided by bottom. You get negative 16.6 repeating. Now, what this is in the context of the problem, you always have to look at the context of the problem. What does this negative 16.6 repeating actually mean as far as the context of the problem? Well, what we just figured out is that the battery life in segment A is going down negative 16.6% each hour. Right? That's how much it's going down each hour. That's what we actually figured out, which is the rate of change. Sometimes you have to look and see. Sometimes we're talking about like distance away from home or total distance traveled, or there's lots of different scenarios. Segment B. Segment B is going from this point to this point. So 3, comma 50. And we're ending up at over to 8 up to 50. So we're going 3, comma 50 to 8, comma 50. Again, all points are written X, comma Y. So 3 is an X, 50 is a Y. 8 is an X, 50 is a Y. 3, comma 50 is your first point. Those get 1s. 8, comma 50 is your second point. Those get 2s. The formula says Y2 minus Y1, so 50 minus 50, over X2 minus X1, 8 minus 3. 50 minus 50 is 0. 8 minus 3 is 5. Top divided by bottom. 0 divided by 5 is 0. So what does that mean? Well, what happened in segment B? We weren't using the phone at all. The battery life did not change at all. It didn't go up. It didn't go down. Each hour, we weren't gaining or losing anything. It was staying the same, right? It was staying the same because that's what that 0% actually means. Take a look at segment C. Segment C, we're going from this point to this point. Again, I'm just going to assume that that's halfway because it looks like it, all right? We're going to assume that that's 25. So we're going from over to 8 up to 50 to over to 16 up to 25. So all points are written X, comma Y. 8 is an X, 50 is a Y. 16 is an X, 25 is a Y. 8, comma 50 is the first point, so these get 1s. 16, comma 25 is your second point. Those get 2s. Y2 minus Y1, 25 minus 50. X2 minus X1, 16 minus 8. 25 minus 50 is negative 25. 16 minus 8 is 8. Top divided by bottom. Top divided by bottom. This is negative 3.125. So again, what we're talking about in the context of the problem, we're talking about percentages here. And so that means the phone charge is going down 3.125% each hour from hour 8 to hour 16. So that's how much it's decreasing each hour. Then in segment D, going from here to here. So we're going from 16, 25. And we're ending at, this would be 20 right here. So 20, 100. All points are written X, Y. So this is an X, this is a Y. This is an X, this is a Y. 16, 25 is your first point. So these get ones. 2100 is your second point. Those get twos. Draw your fraction bar, put your two minus signs. Y2 minus Y1. 100 minus 25. X2 minus X1. 20 minus 16. 100 minus 25 is 75. 20 minus 16 is 4. Top divided by bottom. 75 divided by 4 is 18.75. And in the context of the problem, it would be percent. So what does this mean in the context of the problem? Well, that means when the phone got put back on the charger, it was increasing by 18.75% per hour. So every hour it went up 18, almost 19%. One of the types of questions that you are going to be asked, because it doesn't ask it in the notes here, is where was the greatest percentage of change? All right, where did the rate of change the most? Well, what you have to do is look at which number is the highest, but in the context of the problem, a positive and a negative would be the same thing. You would really be taking the absolute value of these. If this number was higher, let's say that this one was negative 20%, this would actually be the higher rate of change because it was changing the most. When you're talking about the higher rate of change, it's not talking about the most positive number. It's talking about which number is farther away from zero. So in this case, it is segment D that's changing the most. But let's say that this was 20. If this was a negative 20, that would be changing the most. So that would be your rate of change. So let's take a look at some more questions dealing with this. In question number 5, determine which portion or portions, by that they mean which interval, A, B, C, or D, of the graph can be described by the statement. The cell phone was not in use. Is it A, B, C, or D that the cell phone wasn't in use? B, all right? And that is from hour number 3 to hour number 8, all right? From 3 to 8 in the hours. The cell phone battery was recharging. What segment is that? A, B, C, or D? D, all right? And that would really go from, the interval would be hour 16 to hour 20. The cell phone was in use. A and C. The cell phone battery was fully charged. Where was it fully charged? The beginning of A and the end of D. All right, so the beginning of A and the end of D. So at hour 0 and at hour 20. The cell phone battery was halfway charged. B, all right? The cell phone battery was halfway charged. 50% is halfway. Where else? And right here, all right, right there. So at, let's call that hour 17-ish, all right? So in segment B and approximately hour 17. The last slide, determine whether each statement is true or false. If it's false, explain why it's false. The cell phone battery died after 20 hours. False, All right, false. All right, at the 20-hour mark, according to our graph, at the 20-hour mark, it was at 100% at 20 hours. The cell phone battery lost 25% of its charge during an 8-hour time period. Anywhere on there did it lose 25% over 8 hours? First of all, if it's losing, are we looking at the part of the graph that's going up or going down? Going down. So during this part, over an 8-hour period, well, this only covers 3 hours. So can we even look at A? No. How about during C? C is from hour 8 to hour 16. That is an 8-hour period of time. How much percent did it lose in that time? 25. It went from 50 down to 25. So this one is true. Right, it happened in that C section. Letter C. The cell phone was used at the most between the 16th and 20th hour. False. All right. The cell phone was being used the most right there. All right. It was being used the most in A. The cell phone battery was charged twice. False. All right. It was only charged at the end in the D segment. That's where the charge went up. And letter E, after the first 3 hours, the battery had half the charge that it began with. After the first 3 hours. So here's hour 3. We're looking right there. Ding, ding, ding. 50%. It started at 100 and then it ended up at 50%. So that is true. Again, the hardest thing about this section is that rate of change. All right. With the rate of change, you have to use that slope formula. Pick the 2 points, the beginning point, the ending point, sub it into that slope formula, y2 minus y1 over x2 minus x1. Always make sure that you're referring back to what the problem is actually dealing with, the context of the problem, because that will help you answer the questions.